Hello students, in today's video, let us have an understanding about Copernican revolution. We were discussing about ancient perspectives on the universe. We have seen how the geocentric model was developed, especially by Ptolemy and later by other philosophers and thinkers. Now, moving on to the next phase of this perspective on universe, we have a milestone when we come to the 16th century, that is the Copernican revolution. So Nicolaus Copernicus, who lived in the 16th century, formulated a new model for the universe, which is called heliocentric model. Until then, we know geocentric model was widely accepted. Geocentric assumes that Earth is at the center of the universe. So a huge shift is happening in the 16th century when Nicolaus Copernicus proposed that Earth is not at the center. We have a heliocentric model. So helio stands for sun. So in the heliocentric model, sun is at the center of the universe. So in his famous work on the revolutions of the heavenly spheres, he put forward this theory. So as you can see here, when we come into the Copernican revolution, we have sun at the center of the universe and all other planets that were discussed, Mercury, Venus, Earth, Mars, Jupiter, etc. are orbiting around the sun in circular orbits. So what are the main features of this Copernican system? So it observes that sun is at the center with Mercury, Venus, Earth, Mars, Jupiter and Saturn orbiting around the sun. And he could also explain the retrograde motion of the planets. So in the geocentric model, we saw that planets have a retrograde motion. Sometimes it will appear to be moving backwards and sometimes forward. And that was explained based on epicycles in the geocentric model. But here, a more neat explanation is brought by Copernicus. He was able to explain the retrograde motion of planets and especially that of Mars. In the case of Mars, he was able to explain the retrograde motion in different directions when it is near perigee and apogee using simple diagrams. So the complicated concept of retrograde motion was beautifully explained in the Copernican system. Then moon was not assumed simply as a planet in this model. It was observed that moon is a satellite of Earth. In the earlier models, moon was also considered to be orbiting the sun. Moon was also assumed to be a planet. Now moon is assumed as a satellite of Earth. And what are the orbits of the planets? All planets move in simple circular orbits with sun at the center. And this model, Copernican model, did not propose an elliptical orbit because of the aesthetic beauty of circles. He also proposed a circular orbit for planets. So as you see here, in the geocentric model, the motion of the planets was explained based on epicycles and deferent, right? So epicycles are the small circles that the planets take and the deferent is the overall full circle around the Earth. So you can see here how complicated the system was thought to be in the geocentric model. So retrograde motion is observed when planets move backward and then forward. So this complicated model is much simplified when we come into the heliocentric model proposed by Copernicus. So you can see here, when sun is thought to be at the center of the universe or the solar system, we can see all the planets, we can place them in beautiful circular orbits just around the sun. So a simplification of model is happening when we move from the geocentric system to the heliocentric system. Now the Copernican model proposed that if Earth moved, it should show us parallaxes in the positions of the stars. For example, if sun is at the center and the Earth is moving around the sun, we know the period of revolution of Earth is 1 year. It takes 1 year for Earth to complete one full circle. So for the Earth to reach the other point of this circle, it will take 6 months. for Earth to move from one point to the opposite point, diametrically opposite point of the circle, it will take 6 months. So if you are looking at the same star in a 6 months gap, we should be able to record some parallax. Parallax means the difference in angle. For example, if you are looking at the star at one particular month in this direction, then after 6 months, if you are observing the same star, the angle should be changed. The angle of the telescope or whatever observing device we are using, that should be changed. Even if with bare eyes, we need to change the angle we are looking. So that is measured in parallax. So this model, Copernican model, proposed that there should be some parallax in the positions of the stars since Earth is moving. But then we did not have any sophisticated device to measure this parallax. So the followers of the Copernican system believe that the stars are very far away to measure this parallax. If the star is further away, we know the parallax will be very small. The angle will be very small, like this. So the followers believe that the stars are very far away, and that's why we are not measuring the parallax. And this theory was somewhat right, because in the present system, in the current era, with sophisticated devices, telescopes and cameras, we are able to observe this parallax. If we observe a star at a distant point now, and after 6 months, there is a small difference in angle, which is the parallax, and that is now observed. So we can say that the Copernican system, this proposal was absolutely right in formulating a theory for Earth's motion. Now moving on to the next assumption, this model proposed that the apparent daily motion of distant stars is due to the rotation of the Earth. You know, every day the planets and stars as observed from Earth are moving. The sun rises in the east and sets in the west. Similarly, moon rises in the east and sets in the west. All the stars move from east to west at night. This is the daily motion of the stars. And whether planets and stars are moving or are we moving, now we know that Earth is moving. Earth is rotating on a daily basis. So in the Copernican model, it was understood that this daily motion is due to the rotation of the Earth on a daily basis. So we will have day and night in every day. So even the apparent motion of the sun, that means every day sun rises in the east and rests in the west. Here sun is not moving, but the Earth is actually rotating. This was also proposed by Copernicus in his model. Even though the Copernican model was successful in many of the areas, there were some drawbacks for this model. For example, this model insisted on circular orbits. Now we know circle is not the path followed by planets. We have ellipse, and sun is not exactly at the center. Sun is at one of the focal points. So this was one of the drawbacks. He insisted on following this circular path. Then another problem is that he relied on epicycles to explain the variation of angular velocity of planets. We know planets have different angular velocity at perigee and apogee. Also at different positions, they have different angular velocities. So in order to explain this variation in angular velocity, he used the concept of epicycle itself. So these are some drawbacks of the Copernican system. Even though this revolutionary idea of heliocentric model was proposed by Nicolaus Copernicus in the 16th century itself, it did not make an immediate impact. This heliocentric model received much attention only when Galileo Galilei came into the frame. When Galileo tried to propose the heliocentric model based on strong logical reasons and observation, this concept, this heliocentric model was gaining much more attention. So this Copernican model was just remained as a proposal on the paper. It did not get much attention, and now we will see about Galileo Galilei, who further emphasized on experiments, observations and logical reasoning, and who also made this heliocentric model much acceptable to the world. So as of now, I hope that this Copernican model and his revolutionary concept of bringing in the heliocentrism is clear for you. Thank you.